Okay, here is the third video for our midterm review. Pages 26 through 42, all multiple choice questions. So number one says, if y is equal to x cubed plus 1 quantity squared, then dy dx is. This is a chain rule problem. We have stuff being squared here. So derivative of stuff squared is 2 times that stuff, which is x cubed plus 1. And then we must multiply by the derivative stuff, which is 3x squared. Cleaning this up, this is all multiplication here, so we have 2 times 3 is 6x squared, or 2 times 3x squared, 6x squared, parentheses x cubed plus 1, which looks like choice E. Not a bad question at all. Number 3, recorder out of the way here. Number 3 says, for x greater or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function f. So if we were to try to draw this, here's for x positive, we knew that y equals 2 is an asymptote. So what happens is this function, whatever it does, it eventually approaches the asymptote, not necessarily from above, but here is a function with an asymptote of y equals 2. Which of the statements must be true? Well, a horizontal asymptote is talking about behavior as x gets large. So thinking about it as x goes to infinity, and what we're really saying is, hey, that the limit as x gets big of this function, as x gets big, the function value gets closer and closer to the y value of 2. So choice E is correct. Let's just analyze these other ones. F of 0 equals 2. Who knows what f of 0 is? F of 0 could be up here. F of 0 might not exist. Who knows? Part B says, choice B says f of x is not equal to 2 for all x greater or equal to 0. Well, this is really going back to Mr. McCarville's class last year. You learned that a function can cross its horizontal asymptote. In fact, a function crosses its horizontal asymptote infinitely many times, just as long as you get further and further along the line, we're getting closer and closer. F of 2 is undefined. This has nothing to do with f of 2. F of 2 could be perfectly defined. The limit as x approaches 2 equals infinity. Again, this is a horizontal asymptote, not a vertical one. So we're not asking whether or not the function gets big. We're asking as x gets big, what's happening to the function. All right, number 4. If y equals that function, then dy dx equals. So we would like the derivative of a quotient, which requires the quotient rule. So we'll identify the high and the low. High prime is 2, low prime is 3. And so dy dx, low d high is 2 times 3x plus 2 minus high d low. High d low is 3 times 2x plus 3 over low squared, which is 3x plus 2 squared. This is not a choice. We have to go and simplify this, which we can by distributing. We would get 6x plus 4 minus 6x minus 9 over 3x plus 2 squared. So we get the 6x's go away. We get negative 5 over 3x plus 2 squared. Choice D. Whoops. Choice D is correct. All right, next guy. We have this limit as x approaches infinity of this function. Now, a little shortcut here. As x approaches infinity, we have a rational function. They are of of the same degree. So what you can do is simply take the coefficient, the ratio of the coefficients and get 1/4. A couple of things. If you want to do this, not the hard way necessarily, but the more analytical way, what I taught you at the beginning of the year was, if you have this, divide every term by the highest degree that you see in the denominator, which is x cubed. And this will help you see better what is significant and insignificant. So if we see this, if we simplify this, we get the limit as x approaches infinity of 1 minus 2 over x plus 3 over x squared minus 4 over x cubed over 4 minus 3 over x plus 2 over x squared minus 1 over x cubed. And as x goes to infinity, all of these fractions go to 0. And we are left with our 1/4 answer. All right, good. Next question. We have the graph of f prime, the derivative of f is shown above, which of the following statements is true about f? So here's another question where I feel if you draw a little number line of f prime, telling whether it's positive or negative, this will be very easy for us to do. So since the graph of f is above the x-axis, we are positive from -2 to 0, and the derivative is negative from 0 to 2. And so we know the function, the original function, f, is increasing, goes from increasing to decreasing, increasing and decreasing. So f is decreasing from -1 to 1 is incorrect. F is increasing from -2 to 0 is correct. F is not increasing from 1 to 2. F would have a local max at 0 because the function is increasing then decreasing at 0. And f not being differentiable, well, that's not true. F prime is not differentiable. That's because this graph has a corner, so its derivative does not exist. But the fact that f of -1, f prime of -1 is some, say 1, for example, means that the function, the original function, is differentiable at -1 and at 1. So don't get tricked by that. Next question. We have f of x is the natural log of all that stuff. We want to find f prime of 0. Another chain rule question, as you noticed. Chain rule is a big topic on the multiple choice. So I have f prime of x. I have derivative ln of stuff, which is 1 over the stuff, times the derivative of the stuff. Well, the derivative of x is 1. Derivative of 4 is 0. And the derivative of e to the -3x is a chain rule in and of itself. We have e to the stuff. So the derivative of e to the stuff is e to the stuff times -3. So we get f prime of x to be 1 minus 3 e to the -3x over x plus 4 plus e to the -3x. And f of f prime at 0, we plug in 0 into this and we see what we get. 1 minus 3 e to the -3 times 0 is 0 over 0 plus 4 plus e to the 0. So we get 1 minus e to the 0 is 1, so this is 1 minus 3 over 4 plus 1, -2/5. Final answer, choice A. Number 10, the function f has the property that f of x, f prime of x, and f double prime of x are all negative. So what does this mean? Well, f of x being negative means f is below the x-axis all the time. F prime being less than 0 means that f is decreasing all the time. And f double prime of x being less than 0 means that f is concave down all the time. So if we analyze this, we want the picture that's below the x-axis, decreasing, concave down. Choice B. Number 13, the graph of f of the function f is shown above. Where is f continuous but not differentiable? So continuous. At A, we are continuous, but we get a corner. So A, we are continuous, but not differentiable. At B, we are not continuous because we have a hole. And at C, we are not continuous because we have a jump. So there is only one place where we are continuous, but not differentiable. Choice A. Number 14, if y equals x squared sine 2x, then dy dx is. This is a product rule question overall with a chain rule inside of it. So derivative of x squared is 2x. Derivative sine of stuff is cosine of stuff times the derivative of stuff, which is 2. Putting this all together, putting this all together as y prime or dy dx, we would get 2x sine 2x plus x squared times 2 cosine 2x. That is not the answer. We need to factor out a 2x. To get the answer, we would be left with sine 2x plus x cosine of 2x, which is an answer, which is choice E. 15, let f be the function with the derivative given by x, f prime of x equals x squared minus 2 over x, on which of the following intervals is f decreasing? So we need to make a number line here, which involves, first of all, finding critical values. They already were nice enough and gave us f prime. So we need to find out where this thing is equal to 0, and we need to find out where the derivative does not exist. So setting this thing equal to 0, a few ways you could handle this. You could multiply through by x, get rid of the denominator. We would get x cubed minus 2 equals 0. X cubed would equal 2. X would be the cube root of 2. This is not plus or minus, it's a cube root. And where the derivative doesn't exist is where we have 0 in the denominator of one of a fraction, so that would mean x equals 0. These two values must go on your number line. So we would get 0 and cube root of 2 on the number line. And now we have to plug in numbers into the derivative, which let's be very clear about this. This and this are not the same. In terms of equations, the two equations have the same solutions. But the derivative, we really need to be careful here. We need to be plugging into x squared minus 2 over x. So plugging in a number to the left of 0, such as 1, or negative 1. Negative 1 squared is always positive. Minus 2 over 1 is negative. So, oh, I'm sorry. Negative 1 squared, well, anything squared is always positive, and then we're subtracting 2 over a negative value. So negative divided by negative is a positive, so when you add two positives together, you always get a positive. Plugging in a number between 0 and cube root of 2, 1 would work. So we get 1 squared minus 2 over 1. 1 minus 2 is negative 1. This interval we're negative. The derivative is negative. And then past cube root of 2, an easy number is 2. 2 squared minus 2 over 2. 4 minus 1 is 3. Positive. So now we want to find out where f is decreasing. F is increasing from negative infinity to 0, decreasing from 0 to cube root of 2, and increasing after that. So 0 to cube root of 2 is correct. As a side note, the square bracket, again, some books define you can put the endpoint on the increasing or decreasing interval. Some books say you can't. Not really that important here because it's the only choice that makes any sense. All right, number 16 says if the line tangent to the graph of the function at the point 1, 7 happens to pass through the point negative 2, negative 2, then f prime of 1 is. Well, f prime of 1 is the slope of the tangent line at 1. And they told us, okay, well, the tangent line is tangent to the graph at 1, 7, so that's a point. And then they told us another point on the graph was negative of the tangent line was negative 2, negative 2. This amounts to calculating a slope. Slope, negative 2 minus 7 over negative 2 minus 1. So we get negative 9 over negative 3, which is 3. Very easy question. If you understand what to do, it's very easy. All right, number 17 says let f be that function. We want to find out where the function's concave down. So we need the second derivative, which requires us to get the first derivative. So our first derivative of 2x, derivative 2x is 2. I'm using the product rule here. Derivative e to the x is e to the x. So we get 2x e to the x plus 2 e to the x. Second derivative. Well, guess what? We need to take the derivative of 2x e to the x again, but we just did it. It's just this whole blue thing. So I'm going to rewrite the blue part again. But then also remember, I have to take the derivative of 2e to the x again, which is 2e to the x. So remember, derivative of e to the x is e to the x. Derivative of a constant multiplier just comes down. So f double prime of x is 2x e to the x plus 4e to the x. We need to set this thing equal to 0. So we're going to factor out a 2e to the x. What's left would be x plus 2 equals 0. And so here we go. Two e to the x equals 0. Well, e to the x is always positive. 2 is always positive. This has no solutions. X plus 2 equals 0 has a nice solution. X is negative 2. So now we want to figure out where this function is concave down. So we need to make a little number line for ourselves for f double prime. So we only have negative 2 on this number line. Our derivative is 2e to the x. x plus 2. I can use the factored form of the derivative because it is equal to the derivative. There's no manipulation of equation there. You're just manipulating one side of things. So you can use that factored form pretty straight up. 2 to the x is always positive. So if you're to the left of 2, say at -3, this is going, the second derivative is going to be negative. And then if you're to the right of -2, say 0, it's going to be positive. So we are concave down on the interval -infinity to -2, which is the same thing as choice A, like so. Number 18, we have the derivative given as a chart. It's continuous, has exactly 2 zeros. It says that the domain of G is a set of all real numbers, then G is decreasing on which of the following intervals. So if you make a little number line out of this, we'll be able to answer the question real easily. So they told us G prime of x, it has 2 zeros, and only 2. This is important. This is an important fact. At -2 and 2, we know the derivative, I'll pull a little 0 up here, is 0. And then what that means is since the derivative is continuous, if you think about a continuous function, if it has 2 zeros, that means that function has to be positive or negative on these intervals that the zeros break up the number line into. So -4, the derivative is 2, -3, the derivative is 3. That means the derivative has to be positive here along the entire interval. Again, this is because the function's continuous. If it wasn't continuous, you could jump. So for example, if the function was not continuous, let me draw it more accurately. At -4, our derivative graph could be at 2. At -3, our derivative graph could be at 3. At -2, our derivative graph is 0. If the function is not continuous, it could do something bizarro like this. And cross over the x-axis, have negative values. But this problem is avoided because the function's continuous. So if you know that you are continuous and you only have those 2 zeros mentioned, that you're going to be completely above the x-axis for that time. There's no other way to slice it. So from -2 to 2, the derivatives are negative, and that has to happen across the interval. And then at past 2, the derivatives are positive. So G is decreasing on the interval -2 to 2. So we can say choice A is the answer. Number 19, a curve has slope of 2x plus 3 at each point xy on the curve. Which of the following is the equation for this curve as it passes to the point 1 and 2? This is a question that I think you would have to really make some connections to do, but is doable. Since the slope is 2x plus 3, they're really telling us f prime of x is 2x plus 3, and they're really asking us for f of x. So if you think about what they're asking, they're really asking us, let's find the antiderivative and then figure out what function this exactly is. Because if we have the derivative and we want to go backwards, we'll find the antiderivative. So this is just a power rule question. You add 1 to the power, so this is 2x squared, divided by the new power. The antiderivative of 3 is 3x, that's where it came from if you took a derivative, plus c. So right now we know f of x is equal to this. The 2's go away. So f of x is x squared plus 3x plus c. We want to find the equation for the curve as it passes to the point 1, 2. Well, that means when x is 1, y is 2. So if you think about what this means, when I plug in 1 for x, this will result in a function value or a y value of 2. And that will allow you to actually solve for the constant. So 2 is equal to 1 plus 3 plus c. 2 is equal to 4 plus c. Subtract 4. And -2 is c. So now my function is going to be x squared plus 3x minus 2. Sorry, yes, that's correct. So x squared plus 3x minus 2. Choice D. Number 20. Let f be the function given above. For which of the following statements are true about f? Interesting question. We've done these. Limit as x approaches 3 exists. F is continuous at x equals 3. F is differentiable at x equals 3. Well, let's talk about this. Let's actually, maybe a sketch would be appropriate here if we thought about what this means. 3 is the glue point or what I call the glue point, where you're kind of taking these functions and putting them together. So f of x equaling x plus 2 means it's a line having a y-intercept of 2, and it goes up 1 over 1, up 1 over 1, and up 1 over 1. And we're going to fill in because we have an equal part there. And then 4x minus 7, if we think about what that is, that has a y-intercept of negative 7. We'd have to go up 4, 1, 2, 3, 4 over 1. 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 And here, technically this would be looking like this. So now if we take a look, here's our graph. Since the points match up, so I'm drawing the circle as the red circle as an open, but that matches up with your closed, so the whole function looks like this. Here's our function. The limit exists if you use the shutter method, as some of you call it. If you open the shutters from both sides, you would be approaching the same value. It's continuous because the graph has no breaks in it. But it's not differentiable because you get a corner. So 1 and 2 only are the answers here. And a little more analytically, if you think about what this means, if you took the derivatives, you get f prime of x equals 1 and 4 if x is less than 3, if x is greater than 3. Since they don't agree with each other, the function is not differentiable. To check whether the limit exists, just plug in 3 into each piece. 3 plus 2 is 5. 4 times 3 is 12 minus 7 is 5. So this means the limit exists, and since this is the function value at 3 because of the equal sign, the function value equals the limit, so the function's continuous. All right, number 21, here's our second derivative graph. They even gave you a formula for the second derivative, which this question irks me a little bit because you don't need this. You could do the question with the graph or the formula. It says the graph of f double prime is shown above. Where does the graph of f have a point of inflection? So number line is very useful for this. Before we get to a, the second derivative was positive. We leave a and get to the origin. The second derivative is negative, doing the number line for f double prime. Then we get to b, where we get another 0. But if you notice, the second derivative is positive on this interval and then also positive after we leave. So there are 2 inflection points because f is concave up, concave down, concave up, and concave up all the way through. So there are only 2 inflection points at a and 0 only. Choice A. Number 24 says let f be the function defined by that. It says which of the following is the equation of the line tangent to the graph of f where x is -1. You should be able to do this in your sleep. The tangent line equation is y minus y1 equals m times x minus x1. Your function is equal to 4x cubed minus 5x plus 3. The first derivative is 12x squared minus 5. This we're going to use to get the slope. Well, we know a few things. We don't know what y1 is yet. We don't know what the slope is yet, but we know x is -1, so minus -1 is +1. Getting the y value requires us to go to the original function and plug in -1. So we have -1 is 4, parentheses -1 cubed minus 5, parentheses -1 plus 3. -1 cubed is -1 times 4 is -4 plus 5 plus 3. 5 plus 3 is 8 minus 4 is 4. There we go. Our slope would be evaluating f prime at -1, which is 12 times -1 squared minus 5, which is 7. That is not a choice. We need to manipulate the equation to make it look like y equals. So we can quickly distribute here. We get 7x plus 7. Add 4. Add 4. We get y equals 7x plus 11. Choice C. Next guy, 25. A particle moves along the x-axis, so its position is that function at what time is the particle at rest. At rest means we're stopped, which means v is 0. So we need to get velocity, which requires us to take the derivative. We get 6t squared minus 42t plus 72. We're going to set this thing equal to 0. We can factor out a 6. We'll be left with t squared minus 7t plus 12. Keep factoring. T minus 4, t minus 3. And so we can clearly see that the particle would be stopped at 3 and 4. Choice E. That is a very easy question. 26, what is the slope of the line tangent to this curve at the point 3 and 2? We're not solved for y, so we will have to use implicit diff to get the derivative. Take the derivative with respect to x on both sides. So we get derivative with respect to x of 3y squared is 6y dy over dx minus derivative of 2x squared is 4x equals derivative of 6 is 0. When you do this, I like to lump together the negative 2 with something. Derivative of negative 2x is negative 2. Derivative of y is dy over dx. Cross it, and we get negative 2x dy over dx minus 2y for our derivative. We have to get all the dy dx's on one side, all the non-dy dx's to the other. So just to get rid of some negative signs here, I'll add the 2x to this side, and I will add the 4x to the other side. So we get 6y, if you can follow this, plus 2x dy over dx. I'm trying to factor and do this all at the same time. Equals 4x plus, minus 2y. We divide by 6y plus 2x. So dy over dx equal to 4x minus 2y over 6y plus 2x. If you were really interested in simplifying this, which you might be, this would be 2x minus y over 3y plus x if you divide every coefficient by 2. So here's our derivative. We want to find the slope of the tangent line at 3, 2, so we will evaluate this at 3, 2. So dy over dx at the point 3, 2 is 2 times 2 minus 3. Or I can just do that backwards and get it right. So 2 times 2 minus 3 over 3 times 2 plus 3. 2 times 2 is 4 minus 3 is 1. 3 times 2 is 6 plus 3 is 9. 1/9 hopefully is there. And it's not, so what did I do wrong? Yes, so I had it right the first time. This is good. Okay, let's try again. 2x is 2 times 3 minus y, which is 2. So 2 times 3 is 6, minus 2 is 4. That is the better answer, and that is choice B. Whew, good thing I know what I'm doing here. All right, let's go next one. Number 27, we have the function defined by f of x is x cubed plus x. If g of x is f inverse of x and g of 2 is 1, what is the value of g prime of 2? This is where I say make a little chart for yourselves. F and g, which is the inverse. So we know g is the inverse, so we know the point 2, 1 is on the inverse graph. Well, that means the point 1, 2 is on the original graph. So if we want to find the value of g prime at 2, that's what we want to find at the end, we need to find the appropriate value of the derivative of f, and the appropriate value we need to find is f prime of 1. Well, how are we going to do this? We were given f prime of x, so on the side here, we can just differentiate it. So the derivative is 3x squared minus 1. So f prime of 1 would be 3 times 1 squared minus 1, which is 3 minus 1, which is 2. So there's a rule that says if you evaluate the derivative at the appropriate number, then the derivative of the inverse at the appropriate x value is the reciprocal of this number. So we get, oh, whoopsie, sorry. This is a plus sign. This is a plus sign. 3 plus 1 is 4. And so the reciprocal is 1/4. There we go. That's much better. Choice B. And number 28. It says this is a tricky question. So, well, not tricky, but it's a good question. Let g be a twice differentiable function with g prime of x greater than 0 and g double prime of x is greater than 0 for real numbers x. So that g of 4 is 12 and g of 5 is 18. Try to draw a scale version of this function. G of 4 is 12. g of 5 is 18. Now, here's the thing. We know a few things. Since g of x, g prime of x is greater than 0, that means g is increasing. And since the second derivative is 0, that means g is concave up. So what that means is this function looks something like this. So it says, of the following, which of the following is possible for g of 6? Well, if you notice, what happens here is the difference between 4 and 5 is 1. The difference between 5 and 6 is 1. The difference between 12 and 18 is 6. But since we're concaving upward, the difference in the y values has to be higher than 6. Because that's how concave up works. It means the increasing nature of this function is increasing. The rate at which the function is increasing is increasing. So what happens is this value has to be greater. This difference has to be bigger than 6. So whatever this y value is, it has to be bigger. And I've kind of traced over an answer here, but it has to. Let me actually undo that. What I just did there. Undo that erasing. Let me see if I can just bring this whole thing down quite a bit. There we go. What happens is, to get the proper value for g of 6, this value, this jump has to be greater than 6. So this y value has to be greater than 24. So if you notice, all these other values are out, and 27 is the only possible answer. I love that question. I think that's a good question. If you really understand how these graphs work and you've made some connections, this is a fantastic question. And we're done for this video.